Okay, the third order fringe, that means that what n is 3 of 620 nanometer light. So our wavelength is 620 times 10 to the minus 9th meters, is observed at an angle of 21 degrees. So that's our theta. This is definitely not a small angle, right? We're going to have to use this formula. Okay, when the light falls on two narrow slits, what distance? So we're solving for the d. Let's do that. Okay, so 3 times the wavelength is equal to d, which we don't know, times the sine of 21 degrees. Now you have to be in degrees. Make sure your calculator is in degrees. So d is going to be this times this divided by that. Let's do that. 3 times 620 e minus 9 divided by the sine. I'm checking my mode. Yep, I am in degrees. Okay, that's annoying. Okay, so let's see. Sine 21, right parenthesis. Okay. So d ends up being really small. D is 5.19 times 10 to the minus 6th meters, or 5.19 micrometers. The symbol for micro, it's cool. It's like a Greek M or something like that. Okay, so that is what distance separates the slits. We got that, right? Now keep that on your calculator because we'll use that to find B, okay? So it's 5.190196, et cetera, right? Okay. So let's do part B. Okay, so part B. What angle does the second order fringe make with the central fringe? Well, let's do this, right? Now notice that the third order is 21, so you'd be tempted to say that this is going to be, if every fringe is 7 degrees out, right? If this is 7, this is 14, this is 21, right? This guy, the second order that they're asking about, would be 14, and it is close to 14, but it's not quite 14. So let's use this, okay? So n lambda is equal to d sine theta, and they're asking us about the second order, so let's put a 2 in for n. 2 times 620 times 10 to the minus 9th meters, right, is equal to, and then d we figured out was 5.190196, etc., times 10 to the minus 6th meters, right? We figured that out from part A. And then sine of theta. So let's figure out theta, right? It'll be the inverse sine of this times this divided by this. So second sine of 2 times 620 e minus 9 divided by this value. So I'm just doing up arrow and grabbing that and right parenthesis, and indeed I get that theta is 13.8 degrees, right? Okay. So what distance separates the central spot in the second order fringe on a screen 5 meters away? So this thing is 5 meters here. 5.0 meters, that's pretty far. Okay, and I'm going to use, since that angle is not a small angle, I'm going to use the fact that if we look at this angle here, right here, this is S and that's D, right? That the tangent of that angle is S over D, where S is how far apart the fringes are on the screen, right? Or how far the distance is on the screen, and D is how far to the screen, right? So that means that S is D tan theta. So let's do that. 5 times the tangent of that angle, 13.8, is 1.23. Now, just as a side note, if you did this, you'd get 1.19, okay? Which is close, but it's not close enough, okay? So definitely with big angles, you want to use the actual trigonometric relationships. Okay,